Hello, everyone. Good morning.
No,
I'm
no, no,
Felipe.
no. 5, 4, 3, 2.
Hello, good morning, everyone. I'm Felipe, professor at the University of San Francisco in Brazil, and welcome this webinar today for this new series in 2025 of International Test Commission. And today we have the honor to have our President Kadriye as a speaker with the theme of validity and fairness considerations in innovative digital assessment. Before to hand over to Kadriye, I would like to introduce her to our audience today. Kadriye Ercikan is responsible for the ETS Foundation and Applied Research and ETS contract for the National Assessment of Education Progress, PISA, PIAC, and PARAC contracts. Her research focuses on validity and fairness issues and socio-cultural context of assessment. Her recent research includes validity and fairness issues in innovative digital assessment, including using response process data, artificial intelligence applications, and adaptivity. Ercikan is a fellow of the International Academy of Education, president-elect of International Academy of Education, and president-elect of International Test Commission. Her research has resulted in 6 books, 4 special issues of her referred journals, and over 100 publications. She was awarded as a IRA Division D, significant contribution to educational measurement and research methodology recognition for another co-edited volume, generalized for educational research beyond qualitative and quantitative polarization, and received an early career award from the University of British Columbia. Ercikan is currently serving the NCME book series as editor. So welcome and it's our pleasure to have you here on this day, Kadriye. Thank you so much for accepting this invitation for this webinar today.
Hi, everyone. Thank you so much, Felipe, for that wonderful introduction. And hello to colleagues around the world. Welcome to the first ITC webinar series. I know that we have people joining us from more than 40 countries. Thank you so much for joining us across time zones, morning, afternoon, and I know it's evening time for some of you in Asia and further. So thank you. Really excited about starting this webinar series. So feel free to add a greeting into the chat and tell everyone where you're joining from. I'm honored to start the webinar series with a talk close to my heart: validity and fairness considerations in innovative digital assessments. Next slide. Assessments have been transitioning from paper-based assessments to digital environments for several decades now. The integration of AI into assessment, especially with generative AI tools, have accelerated during the last 2 years. The integration is changing the field of assessment and the science of measurement in ways that were unimaginable even 5 years ago. This change, significant re-evolution, requires rethinking new standards, guidelines, and leadership around how AI can responsibly be used in assessment, education, and beyond. The issues of comparability, fairness, validity gained heightened importance in multilingual and multicultural contexts that I know is a really special focus for many ITC members. With the rapid expansion and integration of AI, an urgent need is also emerging to measure more complex competencies. These competencies are needed to be successful in the technologically advanced education and work contexts. Also, we need to provide engaging, interactive learning and assessment environments that are rewarding and beneficial for the individuals involved in these assessments. Provide teachers and learners targeted feedback to support learning. And do this in ways that we can support large numbers of individuals, scalable and efficient ways across the borders. Let's go to the next slide. So I'll start my talk today with a discussion of opportunities in innovations in assessment using AI, present a few examples of innovations, and highlight a need for evaluating validity and fairness of applications. I'll end with a brief final note. First, opportunities. My presentation will focus on applications of AI rather than AI algorithms themselves. The kind of algorithms used have been evolving, shifting from machine learning based to large language models and others. I expect types of algorithms applicable to measurement will evolve over time. My presentation is agnostic to the type of algorithms used in these applications. I'll focus on evaluation of validity and fairness of these applications, irrespective of the type of algorithm that's been used. So first, opportunities for innovation. Key opportunities for integration of AI and other technological advances include not only better measurement, but opportunities to measure complex constructs that are critical for success in education, work, and civic life, which has been difficult to assess using paper-based or linear digital assessments. These opportunities include personalization, interactivity, and adaptivity to meet the test taker where they are and improve engagement and opportunities for doing their best on the assessment. Assessment of more complex cognitive processes through process data, capturing the steps that individuals follow during test taking, automation of content generation and scoring, and provide immediate feedback and support learning. Currently, these opportunities have been taken advantage of in differing degrees. Next. In this next section, I will provide examples of such innovations based on research at the ETS Research Institute, which I lead, that are used to support learning, personalized assessment, interactivity and simulation-based assessment, and increase efficiency for AI-based scoring. Next slide. There have been calls for assessments to directly benefit individuals and support learning. AI can play a significant role bridging learning and assessment. This example I will briefly talk about comes from language learning and assessment context. The learners develop their language by engaging in a simulated workplace context. The tasks require individuals to engage in typical workplace tasks and can be used to assess both language and workplace task performance. The individual navigates through tasks that are personalized based on individuals' task choices and performance on task. Next slide shows how it works, briefly how it works. Personalization and scoring in this example are done using AI, and the individual is presented detailed performance results and personalized recommendations for further practice, also utilizing AI. This type of embedding of assessment in real-life context as well as in learning environment can be used for broader education context, not just workplace-based language learning and assessment. Now let's talk about use of AI in personalizing assessment. Personalization is a key opportunity using AI. The goal of personalization is to advance fairness in assessment by providing opportunities to individuals to demonstrate their knowledge and competencies in effective ways through improving engagement and optimizing performance. One of the personalization projects we're working on at ETS, led by Burcu Arslan and her colleagues, is Context AI. This personalization tool provides on-the-fly personalization based on student-selected interests. The theory of change is grounded in research that highlights the importance of aligning tasks with students' interests, cultural backgrounds, and giving them agency in selecting the kinds of problems they work on to increase their engagement, motivation, and performance. This is intended to promote better assessment and support learning when assessments are grounded in learning environments. And let's go into this demo, Felipe, if you can start playing this demonstration of the Context AI task. This personalization uses GPT-4 in personalizing the context. The individual is given the choice of whether they want personalization or not. They're asked to indicate an area of interest. In this example, the individual enters Roblox, a games company. In this math problem, Roblox is used as the context. We know from previous research, those of you who are doing research on differential item functioning, for example, that the context the items are presented in can affect individuals' performance. So this kind of context personalization is intended to optimize performance of individuals who may have different interests. And of course, you can imagine a variety of different kinds of interests being chosen by individual test takers. Let's go to the next one. This example is focusing on simulation-based assessment. Simulation-based tasks are intended to create real-life-like context in assessment and provide an authentic problem-solving experience. And here's another brief demo, and we can start playing, Felipe. This is a demo of a text-based conversation assessment on weather concepts and is developed by ETS researcher Jessica Andrews Todd and her colleagues. AI was used to program the conversational agents Dr. Garcia, a scientist, and Art, a student peer. At this point in the task, users are asked to engage in a data collection. There's a cloud system moving US context, moving south towards a prediction point in Louisiana. Users need to determine which weather stations on the map are the best options for collecting weather data for predicting a thunderstorm. In this conversation, Dr. Garcia asks about the chosen weather stations and the rationale for those selections. The conversation is adaptive based on the user's responses. And Dr. Garcia, the GPT-4 behind Dr. Garcia response. You will see at the end, Dr. Garcia is subtly questioning the user's incorrect selections. The task captures students' response processes, how they write. As you can see, they go back and forth correcting their responses, and their errors, captures their errors, and their overall final responses to Dr. Garcia's prompts. These are all useful, not just assessing whether the individual provides a correct response, but also useful in assessing the student's scientific reasoning, a complex competency. I want to move on to another application of AI, increasing efficiency. Earliest applications of AI in assessment has been in advancing efficiency, and most widely used applications of AI is creating efficiency in a variety of different aspects of assessments. I'll highlight two different ways AI can be used to increase efficiency of the work done by humans. One type is by replacing the work done by humans, such as the case of content development for tests. Even though human review may be needed, automated content generation results in lower costs and increased capability to generate large numbers of items, which often is needed for test security purposes. A second way of thinking about efficiency is to provide tools to humans that help the users to be more efficient in what they do. I'll provide examples of both of these types of efficiency. Let's go to the next slide. The first example is use of AI to create test content. AI can be used to generate many components of a typical test item. This item involves listening to a question and choosing the most appropriate response. AI can be used to create the question, the correct answer, and the incorrect answers. It can also be used to generate audio input, generate metadata for item management, for example, what type of an item it is, and check other existing items for similarity, a key validity issue. All of these can add great degree of efficiency and replace humans doing the work. Let's move on to the next example showing efficiency in providing feedback to learners. This example focuses on providing information about students' writing, but with a focus on teachers, helping teachers provide the feedback. Teachers use information produced by the automated system to craft their own feedback to students. The idea is that teachers can filter the machine feedback and provide nuance around content, both saving time and allowing the teacher to focus on the things that humans do well, interpreting meaning and contextualizing the feedback. You'll see machine-generated feedback in the middle, and it includes a summary of the writing, evaluation of cohesion and coherence, language use such as vocabulary, as well as mechanics such as spelling. Teacher can then use this machine-generated evaluation to personalize and provide feedback to the student. So this kind of efficiency can be tremendously useful for teachers, as well as for students who can receive the feedback in a more timely, speedy way than if the teacher had to read and evaluate each essay before they can provide feedback to students about their writing. Let's go to the next slide. This slide focuses on efficiency in scoring, and many of you might be familiar with the use of AI in scoring. One approach to increasing efficiency is through combining human scoring with AI scoring. There are three key ways human and machine scoring can complement each other and advance efficiency. I'll highlight verifying scoring quality, contributory scoring, and the divide and conquer approach. With respect to verifying scoring quality, machine scores can serve a confirmatory role for human scores by confirming the human scores and flagging disagreements. They can support quality of human scores by flagging unscorable responses. Flag and review role can also be used to verify machine scores by humans, especially in verifying scoring of unscorable responses. The scores from human and machine scorers can be combined in contributory ways where human and machine holistic scores both contribute to the final score. Or alternatively, they can be used to score different sections of tests. Contributory score can work in a couple of different ways. A parallel contributory approach involves both human and machine scores contribute to the reported scores. Typically, human and machine both provide holistic scores of the same section, with the automated scoring system serving the same role as a second human rater. It can also, the contributory could be also a divergent contributory approach. In this case, human and machine focus on separate aspects of performance. A third option is for humans and AI to produce truly different kind of information. As discussed earlier, machines might be used to evaluate specific, concrete features of responses or measure more fine-grained phenomena, which would take humans a long time to do, while humans evaluate broader and more abstract features of meaning and effectiveness. And I want to highlight one other interesting possibility: to have machines provide quantitative feedback, for example, number of words and so on, while humans provide qualitative feedback. Such qualitative feedback might take the form of comments or coaching, for example. In summary, when considering scoring whether to use humans or machine, it doesn't have to be one or the other. In fact, there are significant benefits to using human and AI scoring. Up to this point, the examples I highlighted were intended to show the promise of AI in advancing innovations that better help assessments better meet its goals of supporting learning, improving engagement, optimizing performance, and advancing fairness and increasing efficiency. In this next section, I'd like to discuss how we can evaluate these applications through a validity and fairness lens. Next slide. For evaluating each of the applications of AI, validity and fairness concepts that you're all familiar with, that we use to evaluate assessments in general, these concepts and the kinds of questions we ask to interrogate validity and fairness play a critical role in evaluating applications of AI as well. There are three key sets of questions that are central to guiding the evaluation of the validity and fairness of claims from each of these applications. to what extent does the AI application meet its targeted goals? What evidence supports intended use and interpretation? Evidence to support use and interpretation. To what extent are these goals met consistently for different groups? Let's take a look at the different applications in supporting learning first. When AI is used to provide automated feedback and support learning, there are many factors that can influence the impact of the feedback, including the nature of the feedback as well as the alignment of the feedback with the individual learner. So we need to evaluate how the automated feedback is affecting engagement and learning. What kinds of evidence support claims about improvement in engagement, possibly using process data or self-report from learners? If there is evidence of improvement in learning outside of the specific learning environment documented by other assessments, and if the evidence supporting involvement in engagement and learning is similarly strong for individuals from different contexts. Let's take a look at the next application, personalizing assessment. Similarly, personalization in assessment needs to be evaluated with respect to its efficacy in improving engagement and optimizing performance for individuals. This evaluation requires empirical evidence to address whether the personalization meets its intended goals of improving engagement, better measurement precision, better alignment with test taker interests and backgrounds. And if there is evidence of improved performance and if there is evidence to support the claims that personalization is improving engagement, measurement, and performance consistently across individuals from different contexts, which is central to fairness. You will recognize that consistency of evidence, consistency of efficacy, I bring up in every application as a way of addressing fairness. Next application, simulation-based assessment, the weather example, for example, that I showed. One of the key goals of simulation-based assessment is to improve engagement and improve measurement of complex thinking through process, through capturing actions, through capturing errors, through capturing how individuals revise their responses. Evaluations of AI applications for simulation-based assessment need to address whether the simulations result in better engagement and better measurement of complex constructs, whether the features in the simulation, digital simulations, and the tools in the simulations are engaging test takers in ways that support measurement goals. Individuals from different cultural, language, education system backgrounds may very well have different familiarity with simulation-based tasks. So we definitely need to also evaluate if the simulation-based assessment is equally effective for individuals from different contexts. And one more example, increasing efficiency. Next slide, please. Automation for content generation and scoring can possibly have the greatest impact on the validity and fairness of claims from assessments. Evaluation of these applications is critically important. For content generation, we need to evaluate to what extent content meets the quality criteria identified for content generation by humans. And if there is evidence of construct irrelevant variance or construct underrepresentation. For AI-based scoring, a thorough evaluation needs to involve how the quality of AI scores hold up against validity and fairness criteria, as is done for humans for other types of items. For evaluating fairness of AI scores, we need to evaluate if the validity evidence is consistent across individuals from different contexts. Again, looking at the fairness issue through the lens of consistency of the evidence supporting use interpretation. Given AI-based scoring is one of the most widely used applications and probably one of the ones with the greatest consequences, I'll delve into evaluating AI-based scoring in the next few minutes. Key validity and fairness questions for evaluating AI scoring. To what extent are scores consistent with human scoring? Given that human scoring is really, we rely on it, we've relied on it, and we know a great deal about how humans and what the requirements are for quality scoring of open-ended questions, there needs to be some consistency with human scoring. Is there evidence of construct irrelevant variance? Is the AI scoring capturing something other than what we are trying to measure? Is there evidence of construct underrepresentation? Is the AI algorithm capturing all aspects of the construct that we are trying to measure? Is there evidence of systematic differences between human AI scoring across groups? This is a key way of evaluating fairness. Concordance of human ratings and AI scores, and this typically constitutes a key validity evidence. Two statistics play a critical role in evaluating the concordance, the weighted kappa and PRMSE. How these statistics are used and thresholds are adopted should depend on a variety of factors, including use context and stakes of the assessment, stakes associated with the scores. We also need to look at relative cost of human versus machine scoring. If the machine scoring is very costly, it may not be worth moving in the direction of AI scoring. For example, if a variety of PRMSE 0.9 and above is typically considered high, which gives us confidence that AI scores will have statistical properties that are very similar to human ratings. And for the most part, automated scores can be used interchangeably with human scores. And this is very unusually high, of course. When you have PRMSE 0.7 or lower, there is very limited evidence to support claims that automated scores accurately measure the skills captured in the response in accordance with the item design and the human rating rubric, and should not be used as a sole score for high stakes contexts. But it can be used as a minimum threshold for using automated scores in practice. Construct representation is really critical for validity. Concordance between human and machine scores is a requirement. However, it is not sufficient for validity of claims based on scores. In addition to human-machine concordance, construct comparability of machine scores need to be evaluated. Comparability between AI and human scores. Especially given the black box nature of many AI scoring algorithms, we need to evaluate both construct irrelevant variance as well as construct underrepresentation. A special focus on construct representation is needed to ascertain specific construct components are really captured by machine scoring. A bit about fairness. There are special concerns that the use of AI scoring may contribute to bias. Evaluation of fairness of AI scores need to be considered from the very beginning of the development of AI algorithms, and checks for fairness must be part of the development of AI scoring models and evaluation. This includes building scoring models using data that represent targeted populations, whether those are different language populations, individuals from different countries, gender groups, and so on. Producing evidence that scores are fair, as we do with scores from human scoring. And there should not be subgroup differences between groups in distribution of errors from AI scores in comparison to human scores, and no differential prediction of human scores. And happy to share more about the guidelines we have developed for AI scoring at the ETS Research Institute. Feel free to drop me an email, and I'm happy to share papers or the guidelines with you. So briefly, a few words as a final note. I've highlighted many opportunities for using AI for assessments to better serve assessments goals and for efficiency. I've also described a key set of considerations, which has been really the goal of this presentation, for evaluating validity and fairness of claims when AI is used in a variety of applications in assessment. Next slide. Validating wider applications of AI to assessment required broad range of evidence that support their use that goes beyond concordance tables. Yes, we need to focus on other evidence that goes beyond concordance tables. Some of this work is ongoing, but there is a lot of research needed to develop, evaluate, and improve methodologies and standards for the valid, fair, and ethical use of AI in assessment, so that test takers of all backgrounds have the same opportunity to demonstrate what they know and can do. ITC, International Test Commission, can play an important role in setting the standards for valid, fair, and responsible use of AI. And I know that there is work that's going on there. And if you're interested, I know some of you may not be members of ITC. Please look up International Test Commission, and I encourage you to join this community, become a member, and take advantage of these kinds of interactions with colleagues around the world who are all focusing on testing and measurement. With that, thank you so much for joining us today. If you have questions or would like to explore collaborations with me or ETS Research Institute, please do not hesitate to drop me an email or send a text through LinkedIn. You'll see my email, kercikan@ets.org. So with that, I'm going to stop, and we have a few minutes for questions. Thank you so much. I see a lot in the chat.
Hi, Kadriye. Thank you so much for your outstanding presentation. For sure, it highlights the biggest issues, biggest development in terms of new approaches for items and assessment. Ariella and I and some colleagues also have been working on using artificial intelligence for different purpose on task development, task assessment. And my research group also work on using artificial intelligence for response bias in general. So I'm very glad to have you here today. So we still have some questions for today. If you, audience, feel free to put your questions on chat, and be glad to address this to Kadriye. But we also have some previous questions that we received from the survey that we run for this pre-registration webinar, and we'll read them, some of them. The first one, I don't have the names that the put the questions. I'll put this one in the. The question is about artificial intelligence and transparency and innovative assessment. The question is, Kadriye, how can artificial intelligence contribute to fairness, and what role do explainability and transparency play, especially in artificial intelligence generated items? Additionally, what's innovative online assessment format for work-based projects show promise in ensuring fairness, reliability, and validity?
Thank you for that question. It's very comprehensive and touches on a lot of things. So I'm going to try to remember the first part about how can AI support advancement of fairness in assessment and measurement. So a few different ways. One is, as you may remember in my presentation, focus on personalization. AI can really facilitate adapting assessments to individuals' interest levels, to their backgrounds, to their where they are in their learning journey. So that this is one way to do that. But I also want to highlight that not all personalization is going to lead to fairness, and so we need to evaluate the degree to which those targeted goals are reached. What role the explainability and transparency play? An excellent point, especially in AI-generated test items. The AI-generated test items in some ways are easier with respect to evaluating the degree to which they align with what we are trying to measure. So the humans are always in the loop, evaluating the degree to which what's generated by AI really aligns with the guidelines, standards, assessment framework, curricular framework, and so on and so forth. So, but you may also be referring to item generation on the fly. I think item generation on the fly is a possibility. After a lot of research and evaluation, and it may be restricted to only certain types of items, so that you don't have items generated that really don't align and can derail the test taker. So it's possible to do that, but on the fly item generation. Explainability and transparency is also perhaps even more so critical for scoring. And with going in the direction of large language models, using large language models, and even machine learning, I mean, we don't have a lot of explainability and transparency. So I think really vetting, evaluating the scores that come out. So different strategies. One is really evaluating the qualities of the AI-generated scores, but also not relying solely on AI-generated scores. That adds other scores that have clear explainability and transparency. So the human and AI collaboration, different ways that I talked about, can really be another approach to adding the explainability and transparency. We can call it explainability, transparency, or validity. So I think these are really central to making valid claims about the scores that are generated. Thank you for that question.
Thank you. I also have some questions from the chat, and I guess Ariella can make one of this.
Okay, can you hear me?
Yes, yes.
Okay, so Professor Anna Brau asked, she said, I hear from some test content developers that their jobs will be gone in the next few years because of AI. Do you agree with their concerns?
I don't think we can do testing, which plays such a critical role in society, with human expertise. The expertise that you as measurement experts and content experts bring to the table is critical for valid and fair assessment. Are we using AI to generate items? Yes. And do we need fewer content developers? Yes. I'm afraid all our jobs are on the line, that AI is going to replace some parts of our jobs, and maybe not as many of us will be needed. I mean, including psychometric analysis and so on and so forth. Yes, I think efficiency means that you need fewer people to do the job, and it will go in that direction, that some of the tasks that are that used to be done by humans will be replaced, are being replaced by machines, but I don't see any time in the near future that they will be completely replaced by AI and machines.
Yeah, sure. Excellent answers. Probably is some concerns that, as in mind from researchers, applier, test takers, and so forth. And it's very important to see that probably be change it, but not replace it. Yes.
Yes.
And yeah, we still have one question from the previous pre-registered members. It's about validation and personalization in large-scale testing. The question is, what process are being developed to validate or equate assessment items in large-scale tasks while allowing personalization? Example, math questions in real world versus abstract contests. How can we ensure comparability when accommodation diverse learner needs?
Excellent question again, and very thoughtful. So it's definitely relevant to validating and providing fair scores to individuals who may take very different versions of an assessment. So and personalizing being different than computer adaptivity. You are all familiar, I expect, about computer adaptive tests that are really focusing on aligning the test to individuals' previous responses. Personalization uses some of that, but goes beyond that. So example I've shown in personalization of the context. How do you then create comparable scores if individuals take somewhat different formats, somewhat items in different contexts, and so on and so forth? This is an active area of research here at ETS. Sandeep Sinharai is involved in doing some of this work. I encourage you to also read Bob Mislevy's 2017 book, I believe, Sociocultural Context of Assessment, or Sociocognitive Context of Assessment. What basically you advance validity of an assessment if the responses to test questions are better aligned with the individual and the individual has a better choice to demonstrate their knowledge and competencies. And I presume that's a given. But then how do you evaluate it? So there are different ways. One is really focusing on equivalence of evidence. A lot of standardized testing or measurement, our current paradigm of measurement, it really focuses on equivalence of data, equivalence of observations. Personalization really requires us to step back and think about equivalence of evidence with respect to the construct that you're trying to measure. It's a lot of research a lot of research to be done in this area, and I encourage you to focus on it. And if you make progress in this area, let me know. Sandeep has published some papers on it, I believe, most recently in JEM, Journal of Educational Measurement. Feel free to look that up. But it's an active area of research, and it's definitely something to. One other thing I want to mention before I drop this is that based on our measurement principles, one way to get around that kind of variation in how what individuals take in a personalization context is also provide some common elements that individuals take across the testing experience and align them and create comparability through those comparable elements.
Thank you, Professor Kadriye. We have one more question from the subscription. So they asked, in balancing innovation with psychometric rigor, how should institutions approve the trade-off between assessment of it, like gamified task or real-time data capture, and establish standards of reliability and validity?
Mm-hmm. Mm-hmm. Yeah. How to balance that? I don't think we should be doing innovation for the innovation's sake. I think it's we really should be focusing on leveraging technological advances if they really help us do better measurement and measure things in better ways than we've been able to do. There is a lot of room for improvement in the field of measurement and room for improving our standards as well. What we called rigor is based on giving everyone the same test. And we've learned a great deal that may actually not be the best way to measure individuals' complex competencies who have different learning experiences, who come from different cultural and language backgrounds. So I think on one hand, we have an obligation to do a better measurement, given recognition of our limitations in our current measurement methodologies. On the other hand, technological advances provide opportunities to solve some of the challenges that we have faced in the past. So I would say focus on better measurement, and that may or may not be how we used to measure, and add technology if it helps with better measurement.
Yeah, thank you. I also agree that we have many centenary problems on assessment, and artificial intelligence and new development on technology can maybe help us to solve those problems for sure. We still have one question. This is about more suggestions, Kadriye. The question is made by in YouTube chat. Milena asking, according to what was presented in the section, what resources could be recommended to start learning about and making correct use of artificial intelligence in the evaluation process? How to start learning?
Yes, thank you. There are several guidelines out there for most of them focusing on applications of AI in education. For example, UNESCO has a set of guidelines. ETS Research Institute has released a set of guidelines. Please drop me a note, and I'm happy to send those guidelines to you. I'll send you the link for the guidelines that focus on AI guidelines for applications in assessment and measurement. I am not familiar with a comprehensive book at this point, but I have been involved in a couple of special issues of journals. One is for JEM, a Journal of Educational Measurement, that's going to come out very soon. And another journal published from Turkey on educational measurement. So happy to connect you to those resources as well. Or come to the ITC conference in New Zealand in 2026. ITC has in-person conferences every other year. We met in Granada in 2024, which was an excellent conference, and then 26 will be in New Zealand, and we have we have workshops as part of the conference, as well as typical conference presentations. Colleagues share about the research that they're doing. Those are not very concrete, but happy to provide you some more direct information, Milena, if you drop me a note.
Oh, thank you, Kadriye, for the answer. For sure, it's interesting points how to learn and the ITC conference for sure is something somewhere you can take so much learning from that. We also almost running out of time, and I would like to say thank you again, Kadriye, for this webinar. For sure was lightning on these topics for me for sure, and for sure for the audience as well. And thank you, Ariella, for also help me for this moderation. And I also would like to let you know that we been starting new webinars monthly, about 7 or 8 webinars a year. And the upcoming webinar will be in May, 8th May. And Dragos will be the keynote speaker, and they will speak about test adaptation, reporting standards, the guideline. So join us for the next webinar, and thank you again for being here today. Thank you so much. Bye-bye.
Thanks, Felipe. Thanks, Ariella. And thanks all for joining us. See you at the next webinar.
See you.
Thank you. See you.